In previous lessons, we discussed the fact that member functions have direct access to the members of the particular class. That is, whether they are member functions or member variables. So in this example, I have the class entity again. In the private section, I have the integer called the member. And then I have a set member function, which takes in an argument to set the member to. And then I assign the member parameter to the member to change the state of the particular instance. The point of this is the member function setMember has direct access to the member. As discussed, friend functions also have direct access to the members. But as we've seen with lambda expressions, such as what we have here, as we've seen in the previous lecture, those do not have access to the members from the outside scope. So we actually have to specify explicitly the ones that we want access to. So again, in this example, I'm simply using the entity class constructor, which will print this out right here. Entity constructor invoke the member is member, and then I have a destructor as well, which will do something similar. Entity destructor invoked member was, and then the member. Then we have this toString member function as well. And currently all I'm doing is I'm defining and I'm invoking this lambda. Now, of course, you can do the console output statement directly within the toString body, but I want to use this as a simple example of why we want to capture the this pointer within lambdas. Otherwise, we will not have access to the members of that particular class. In this lambda expression, we are capturing the this pointer. Then we have the parentheses, then we have the body, and then I'm invoking it right here. So when we call the toString, we will invoke the lambda. You can see I end that off with the semicolon. Within the body, I'm going to print out from the entity toString, and I'm going to print out the member. In the main function, I instantiate the entity class. I pass in 55 for the construction, so the member will be 55. Then I do entity1.toString, and if I build run, this will work fine. We get the construct invoked, and we get from entity toString, we get 55, and then we get the destructor as well. Now what happens if I do not capture the this pointer within the lambda? If I build that, we will get an error. Requires the compiler to capture this. Now you can also capture all. You can capture all, for example, but it is best to capture this. And that will basically work, but from C++20 you'll get a warning. So it's best to capture this. Remember, in previous lessons I discussed the fact that member functions basically have a hidden this parameter. So for example, passes a pointer to itself, so we can do this member, and lambda functions do not have access to this pointer. And because of that, we have to pass in this. So we pass in this to the lambda, and with that we have a reference to the particular class, in this case entity. So to the particular instance, we can now access the member on that. This was just a simple high-level example on capturing the this pointer, just in case you try and use lambdas within your class definitions and you run into issues where things don't compile. And of course I'm invoking it right here, but we can also assign that an identifier. So I assign the lambda an identifier, and then I go and invoke it in the next statement. And if I go and build a run now, this will work fine. And with that, we are going to wrap up this lecture on capturing the this pointer.